The fun-sized Snicker bars are supposed to weigh 20 grams. Because the penalty for selling candy bars under the advertised weight is severe, the manufacturer calibrates the machine so the mean weight is 20.1 grams. The quality control engineer at M&M Mars is concerned about the calibration. He obtains a random sample of 11 candy bars, weighs them, and obtains the data shown in this table down below. Should the machine be shut down and calibrated? Because shutting down the point is very expensive, he decides to conduct the test at the 1% level of significance, or alpha 0.01. So we could build our hypothesis test first. The null hypothesis is that the mean weight is 20.1 grams. The alternative, since we want to see if the plant should be shut down, notice how it doesn't say anything about if it is greater than or less than that value. Just then we want to know if it should be shut down. This will be that the mean then would be not equal to 20.1. Now for this, we have that data table there on the bottom, and I have the data table here, which will be on Blackboard. But we're going to copy this data. Actually, we could copy the title too, why not? And toss that into our template. Okay. And then we could uncheck this use similar statistics button, and it will allow us to run our hypothesis test, which automatically calculated for us. Now for this, we wanted to use a level of significance of 1%, and the test population mean is 20.1. This gives us a lovely p-value over here. Yeah, when we need this to be not equal to first, actually. This gives us a p-value right here of, well, we first need the t-stat. That's 1.04. So the t-statistic is 1.04, and the p-value is 0.3226. And we can check out this last tab here to see the histogram according to this, which doesn't particularly appear to be approximately normally distributed or anything, due to the fact that we are only using a sample size of 11 for this. But based upon this, though, we could still give a conclusion for this, since this p-value is going to be greater than 5%. So we cannot reject the null hypothesis. So the conclusion that we can make for this, and let me expand this so I could type. There we go. At the 5%, 1%, and I just realized I used 5% here. Not like that really changes the answer to this. 1%. At the 1% level of significance, we do not have sufficient evidence to reject the null hypothesis. We do not have sufficient evidence to reject the null hypothesis. Which then, that also means then, because we were asked, should the machine be shut down and calibrated? no, the machine should not be shut down and calibrated, since that hypothesis test showed that the alternative cannot possibly be true.